last time we started taking a look at section 2.4, the chain rule, and we had encountered this rule where we took the derivative of the outside of some function and we left the inside, like what's underneath the radical or what's inside of the angle or what's inside of the power. We left that alone, didn't change it. And then after that, we took the derivative of the outside and the inside and we multiplied it by the original derivative piece that we already had written down. So this is the rule that we started with last time. And we had done several examples, and we had gotten to number 7. So number 7 says we're going to evaluate the derivative of the function at the given point, and then use a graphing utility to verify the result. So we've used graphing utilities to verify these results before, so we're going to see again how that works, a reminder on that. But the first thing is we've got to be able to take this derivative. Now, we could do this with the quotient rule, and if you did, that would be okay. There'd be nothing wrong with that. I do want to show you how it looks, though, to do it with the chain rule, just so you know you have an option. I kind of like doing this one with the chain rule. The quotient rule doesn't really sort of beckon to me, and the reason it doesn't is because I've got a constant on top. Anytime I see a constant in part of my function, I don't tend to use the quotient rule. That's just a personal preference, really, more than anything. So if you want to use the quotient rule, you can, but we're practicing the chain rule, so we're going to practice the chain rule together.
I have a question.
Yes?
Can we put 5 out?
You can pull the 5 out, and I'm going to pull up the x cubed minus 2 to the numerator. And what do I have to do if I pull it up to the numerator? To the power negative 1. We saw that happen last time. Good. You guys remember. So I haven't done actually any calculus yet, right? That's just rewriting with a little bit of algebra. Now we're ready to do calculus with the chain rule. So the chain rule says, first of all, the 5 on the outside is just going to stick along with us. It's a constant multiplier, okay, coefficient. What do I have to do when I used red last time, so we'll keep using red. All of this is red, so the stuff that's in red raised to a power negative 1. That negative 1 is what's on the outside. So what do I do when I have a power of negative 1?
Multiply the 5.
Right. I'm going to pull it down and multiply it by the 5. And then what will my new exponent be?
Negative 2.
Negative 2. Okay, so that's the outside part. What do I write inside that parenthesis set?
Red.
X cubed minus 2.
Everything that's in red, right? The x cubed minus 2, exactly. I don't ever change the part on the inside when it's on the inside. I just rewrite it. All right, and then I have to multiply it by the derivative of what is in red, or what is inside, and what would that be?
3x squared.
3x squared. Fabulous. Now, we're going to clean it up just a little bit, not because we have to, but because we're going to evaluate this one, and so it's going to be a little bit more friendly to do that with this particular one to rewrite. Sometimes I don't clean up anything when I'm going to evaluate. But this one has a negative exponent, which makes it a little bit awkward, and so I don't want to deal with the negative exponent when I do that, so I'm going to rewrite it first. All right, the 3x squared at the end and the negative 5 at the beginning, those two pieces, I can combine. They will both be in the numerator to be negative 15x squared on top. And then I'll move the x cubed minus 2 back to the denominator, but this time it will have an exponent of 2 instead of the original exponent of 1. Now, our goal is to actually evaluate this at this particular point, and truth be told, we don't really need the y coordinate on this one. We just need the x coordinate. We just need x equal to 2. So we've talked before about ways to do that. One way is to write this vertical bar. You can write x equals negative 2 down here. Another way to write that is to simply evaluate it at the beginning and write down f prime of negative 2 here. Either which way you write it, you're going to be evaluating this at negative 2. So I have negative 5 times negative 2 squared, which would be 4. I'm sorry, not negative 5, negative 15, and then the 4. And then I have negative 2 cubed. What is negative 2 cubed?
Negative 8.
It's negative 8. So I have a negative 8 minus 2, and then that's squared. So what do I get on top?
60.
Negative 60.
Negative, yeah.
What do I get on bottom?
100.
100, and it's positive, right? So you can either reduce this to a fraction, it would be 3 over 5, or you can reduce it to a decimal, negative, and then, or a decimal. What would the decimal representation be?
Negative 0.6.
Negative 0.6. And either one is fine. If you had gotten a repeating decimal, we really wouldn't want to use the repeating decimal notation, but if it's a terminating decimal, it's okay. Okay, so either of these, I tend to use fractions. So that's the one that I will tend to use. What I'd like to do, though, is to show you or remind you how you can verify it with your graphing device, your calculator. So grab a calculator. I want you to put the original equation into y1. Let's try it again. Alright, so this is what I put in my calculator screen. 5 over x cubed minus 2. I know some of yours look prettier than mine. And then back in the regular screen, okay, regular screen, you do math. Do you remember which option it was? 8. The notation's different depending on the calculator you're using. Mine requires me to tell it y1, vars, y vars, function y1. That's my function. I put a comma and x, comma, -2, because that's where I'm evaluating it at. That's what my notation looks like. And there's that -0.6. So I'm going to swipe yours, I think. Do you mind?
No, right, you.
Okay. Pretty sure Moody's had the math text type, just to remind you. So he's got it in here. It looks beautiful compared to the notation for mine. Okay. And then back in the regular screen, you do math 8. It's dx here. It's y1 here. You get y1 by hitting vars, y vars, function y1. And we're evaluating at -2. And you get that same decimal approximation. Remember, it is approximating it. It's using numerical techniques, not really using calculus to do it. So it is the answer that we're expecting. Okay. Any questions on that? Thank you, Amy. All right. We have one more example, and it says something about graphing utility. So let me just flip this down for now, and we'll bring it back up again in a sec. All right, last one for this lesson says to find an equation. Oh, let me make a comment. On your gateway, you won't be finding any equations. There's none of that going on. It's just find the derivative, find the derivative, find the derivative. It's 20 find the derivative questions, okay? So this one says to find an equation of a tangent line to the graph of f at the given point. And then it says to use the graphing utility to graph the function and its tangent line at that point, okay? So we have a pretty basic function here. We could do this by actually multiplying this out, right? Yeah, we definitely wouldn't have to use a chain rule in this problem. We're going to because we're practicing for the chain rule, but we could do this in another way. So if we're taking the derivative with the chain rule here, what is my outside function? The power 2, the part with the power 2. So I'm going to take that power of 2 and I'm going to bring it down. So I'll highlight everything inside is in red. I'm bringing my 2 down. And then my new exponent will be a very unexciting 1. Yeah. What goes inside the parentheses?
4x cubed plus 3.
Right. 4x cubed plus 3. The exact thing that was inside the parentheses before. Excellent. And then we're going to be multiplying this by the derivative of the 4x cubed plus 3, which is what? 12x squared. Okay, is everybody good with that? Okay, so this is one of those ones where if you weren't being told you're finding a tangent line, you would definitely multiply this out, clean it up, correct? But we're supposed to be finding a tangent line at a very specific location, -1, 1. That is x equals -1. We can just plug -1 in. There's no reason to clean anything up here. I don't have any exponents to put back in the denominator like I did on the last one. So I'm not really inclined to do a whole lot to clean this particular one up because I'm going to be evaluating it anyway. So we're going to draw our line over here. This is going to be evaluated at x equals -1. So if I've got a 2 in front, I'm just going to leave it as a 2. What happens when I take was it -1? Yeah, -1 to the third. That's -1 times the 4 gives me -4, and then I've got my 3 here. I know we could add the 3 as well, but I'll just do a couple of steps of simplification. What happens when I do -1 squared?
1.
That's 1, and then times my 12 is 12. Okay, so I've got 2 at the beginning. What's inside? What's negative 4 plus 3?
1, negative 1.
That's a negative 1. So I've got 2 times negative 1 times 12.
Negative 24.
This is negative 24. And this is the slope, right? That's what I was finding is slope for my tangent line. So if I were doing a tangent line now, y minus y1 equals m times x minus x1. I just found out that the m is negative 24. What else can I fill in? Yeah, x1 and y1. So what is y1? It's actually 1. What is x1? Negative 1, so I've got opposite of negative 1 or plus 1 here in a second, right? X plus 1. This does say an equation, so technically you could stop. I have a feeling your WebAssign is going to want you to write down y equals. So let's just go ahead and do that really quickly. And in order to verify with our calculator, we're going to need to do that anyway to get it into y equals. So we're going to take this. I've got y equals. I have negative 24x. I have the negative 24 times the positive 1, so that's plus 24. And then I have plus 1 from the left-hand side moved over. Yes, it should. Thank you. This should be negative 24. Thank you. I have 3 negatives, so I've got another negative. Thanks. So we end up with y equals negative 24x minus 23. That's the equation of my tangent line. So if you grab your calculator, what we're wanting to put in is the original function. And the tangent line. And we need a window that kind of makes some sense for us. You could probably try the negative 10 to 10. I don't know that it's going to be all that helpful because this is a very steep slope, right? It's going to be very vertical, almost vertical, I should say. And our x value that we're wanting to sort of centralize around is the x value of negative 1. So maybe we could go something like negative 2 to 2, just to give us some perspective. My y-axis, I don't know what I need, so let's just go negative 5 to 5, and we'll see if that works, just to guess. And we'll graph it and see what we get. It's not too bad. We can see the part of the graph we care about, which is this piece right here where the tangent line is hitting the graph. Doesn't look like I need anything on the lower part of the axis, so I'm going to change my window just slightly. So my y minimum is 0, and my y maximum is maybe a little bit higher. There you go. So you can see the tangent line hitting right over here. So if you're sketching this graph,
Would this be a problem or would you need to sketch it?
if it tells you want to. This one did say that, I believe. It says use a graphing utility to graph the function and its tangent line. So this is probably one where on WebAssign they would actually give you a multiple choice kind of graph. That seems to be what they do a lot with their graphs. And so you would probably want to verify that what you're getting on your screen matches what you're expecting to get. This looks something like this. And then my tangent line is over here. Very, very steep. Like this. And it would be very wise for you to go ahead and mark that this is at negative 1, because that's the whole point, is that the tangency, the point of tangency is at x equal negative 1. Everything else is a sketch, truly. Okay. Is that good? No problem? Because we're about to change gears and it's going to get more complicated. I know, you just thought it was already complicated. All right.